What do you do when your entire $900 million program investment becomes worthless overnight because a foreign company goes bankrupt? In February 1971, Lockheed executives received the phone call that would change aviation history forever. Rolls-Royce, the British engine manufacturer powering their revolutionary L-1011 TriStar, was entering bankruptcy. Production stopped, orders were canceled, and suddenly, America's most innovative airliner program faced severe delays. The company that had been a leading post-war airliner maker during aviation's transition from propellers to jets was now bleeding $38.5 million more than they owned, facing a serious corporate crisis, though Penn Central's 1970 bankruptcy remained the largest at the time. But how did a company with such commercial aviation dominance reach this point, the golden age that built an empire? The same company that would later become synonymous with military aerospace dominance once ruled commercial aviation with unprecedented authority. By the 1950s, Lockheed had achieved what few aircraft manufacturers ever manage. They were a leading post-war airliner maker. Their Burbank facility operated as aviation's equivalent of Detroit's Golden Age, producing aircraft that defined how the world traveled. The Lockheed Constellation established the template for modern passenger aviation. Its distinctive triple-tail design wasn't just aesthetic engineering. It solved critical structural problems that allowed for larger, more stable aircraft. The pressurized cabin technology transformed transcontinental flight from an endurance test into comfortable transportation. Passengers could fly from New York to Los Angeles without oxygen masks, without freezing temperatures, and without the bone-rattling turbulence that plagued lower-altitude flights. Airlines recognized the Constellation's competitive advantage immediately. Pan American World Airways, Trans World Airlines, and British Overseas Airways Corporation built their international route networks around Lockheed's aircraft. The Constellation's impressive range opened previously impossible direct routes, while its passenger capacity and reliability made airline operations profitable on routes that had been marginal with earlier aircraft. However, this market dominance created a dangerous corporate psychology within Lockheed's commercial aviation division. Success bred overconfidence in their ability to predict market demands and technological trends. The company's leadership began to believe they could anticipate airline needs better than the airlines themselves. They assumed their engineering excellence would automatically translate into commercial success, regardless of market conditions or competitive responses. The Burbank production lines stretched across multiple hangars, with partially assembled Constellations moving through stations where skilled technicians installed complex pressurization systems, navigation equipment, and the intricate triple-tail assemblies that required precise engineering tolerances. The facility employed thousands of workers who had successfully transitioned from wartime military production to civilian aircraft manufacturing. This transition from military to civilian markets appeared seamless on the surface. The company had leveraged wartime aviation advances, pressurized cabins, long-range navigation systems, and advanced metallurgy to create superior commercial aircraft. Their military experience with complex systems integration gave them advantages over competitors who focused exclusively on civilian markets. But the same innovative culture that created the Constellation's breakthrough design would soon become Lockheed's greatest liability. The company's engineers consistently pushed technological boundaries, often prioritizing advanced capabilities over proven reliability. They approached each new aircraft program as an opportunity to implement cutting-edge systems, assuming that technical superiority would overcome any market resistance. The Constellation program established performance benchmarks that created unrealistic expectations for future Lockheed commercial aircraft. Airlines expected each new Lockheed design to deliver the same revolutionary improvements that the Constellation had provided over its predecessors. This pressure to exceed their own success led Lockheed to pursue increasingly ambitious technical solutions for subsequent aircraft programs. The financial success of the Constellation program also masked underlying vulnerabilities in Lockheed's commercial aviation business model. The aircraft succeeded during a period of rapidly expanding airline markets when carriers needed any reliable long-range aircraft they could obtain. This demand environment allowed Lockheed to command premium pricing for advanced technology, but it wouldn't last forever. By the late 1950s, Lockheed's commercial division operated with the confidence of a company that had never experienced a major program failure. Their market leadership represented the foundation for expansion into new aircraft categories and new technological frontiers. The leadership believed their golden age was just beginning. They were about to discover how quickly cutting-edge innovation could become a catastrophic liability. The turboprop gamble that shattered confidence. The L-188 Electra represented Lockheed's calculated entry into the turboprop market, designed specifically to compete with the Vickers Viscount on short to medium-range routes. This wasn't an attempt to challenge long-range jets like the Boeing 707. The Electra targeted a different market segment entirely: regional and domestic operations where turboprop efficiency and shorter runway capabilities provided distinct advantages over pure jets. The aircraft promised to expand airline route networks significantly by accessing smaller airports that couldn't handle jet operations. Airlines could operate profitable services on routes that were marginal with existing aircraft, while the turboprop engines offered superior fuel economy compared to jets on shorter distances. The Electra's design incorporated lessons learned from the Constellation program, featuring advanced systems integration and passenger comfort features that positioned it as the premium choice in its category. However, September 29, 1959 changed everything for Lockheed's commercial aviation future. Braniff Airways Flight 542 disintegrated in midair near Buffalo, Texas, killing all 34 people on board. The aircraft simply came apart during normal flight operations, with no warning signs or emergency communications from the crew. Less than 6 months later, on March 17, 1960, Northwest Airlines Flight 710 suffered an identical fate near Cannelton, Indiana, with 63 fatalities. Two nearly identical catastrophic failures within such a short time frame pointed to a fundamental design flaw rather than isolated incidents or operational errors. The true cause appears to be whirl mode flutter, a deadly resonance phenomenon between engine nacelle vibrations and wing structures. When engine mounts weakened, often from hard landings that created stress fractures, the compromised mounting system allowed engine vibrations to interact with the wing's natural frequencies. This created oscillations that built upon themselves until the wing structure literally tore apart from the aircraft. The FAA's response was immediate and devastating to the Electra program. Initial speed restrictions reduced the maximum structural cruising speed from 324 knots to 275 knots. Emergency airworthiness. Directive 60-09-03 imposed even more severe limitations. Maximum structural cruising speed dropped to 225 knots, with a never-exceed speed of just 245 knots. These restrictions destroyed the Electra's competitive advantage overnight. The aircraft could no longer maintain the speeds that made it attractive to airlines operating time-sensitive routes. Airlines began canceling orders en masse, as the speed-restricted Electra became uncompetitive with both existing turboprops and emerging jetliners. Lockheed faced near bankruptcy as confidence in their engineering capabilities plummeted across the aviation industry. By the program's end, only 170 Electras were built total, far below the numbers needed for profitability. The same innovative engineering culture that created the successful Constellation had produced a commercial disaster that nearly ended Lockheed's civilian aircraft operations. The company initiated the Lockheed Electra Action Program, collaborating with NASA to identify the fundamental design flaws. Investigations revealed that wing intermediate ribs were subjected to loads from shell distortion that hadn't been accounted for in original design calculations. The dynamic response of outboard nacelles in turbulence differed significantly from design assumptions. Lockheed redesigned engine mounts, nacelles, and cowlings while strengthening wing structures to prevent whirl mode flutter. However, the damage to their commercial reputation was permanent. Airlines had lost trust in Lockheed's ability to deliver safe, reliable aircraft for passenger service. The Electra disasters demonstrated that technical innovation without comprehensive testing could destroy decades of reputation building in months. Lockheed would soon discover that their appetite for cutting-edge technology remained unchanged, even after such devastating consequences. The comeback jet that bet everything on unproven engines. The L-1011 TriStar emerged from Lockheed's determination to reclaim their position in commercial aviation through technological superiority. This wasn't just another wide-body aircraft. It was designed specifically to compete with the McDonnell Douglas DC-10 in the medium-range wide-body market, offering 256 passengers in mixed-class configuration with a range of up to 4,250 nautical miles. The TriStar incorporated revolutionary systems that promised to redefine passenger aviation standards. The aircraft featured an advanced autoflight system with inertial navigation, while the direct lift control system provided unprecedented approach precision. The Cat 3 auto-land capability allowed pilots to land in very low visibility conditions, later achieving Cat 3B standards at some operators. The cabin pressurization system maintained lower altitude equivalence than competitors, reducing passenger fatigue on long flights. However, Lockheed made a decision that would prove catastrophic for their entire commercial aviation future. They committed the TriStar program exclusively to the Rolls-Royce RB211 engine, an unproven power plant that existed primarily on engineering drawings rather than test stands. The RB211 represented a radical departure from conventional turbofan technology. Its three-spool design featured carbon fiber fan blades and advanced materials that promised significant improvements in fuel economy and noise reduction. The engine's bypass ratio exceeded anything previously achieved in commercial aviation, theoretically delivering operational costs that would make the TriStar irresistible to airlines. But here's where Lockheed's engineering culture became their greatest liability. While Boeing offered the 747 with multiple engine options from Pratt & Whitney, General Electric, and Rolls-Royce, Lockheed designed the entire TriStar around the RB211's specific dimensions and performance characteristics. The aircraft's S-duct configuration for the tail-mounted engine, the wing-mounted pylons, and even the fuselage cross-section were optimized for this single, untested power plant. The RB211's development problems became apparent as early as 1969. Rolls-Royce discovered that carbon fiber fan blades shattered during bird strike tests, requiring a complete redesign using titanium blades. The three-spool architecture created vibration issues that demanded extensive modifications to bearing assemblies and shaft balancing systems. You need to understand the financial mathematics that trapped Lockheed in this arrangement. By the time of the crisis, the company had invested over $900 million in the TriStar program throughout its development period. The aircraft's entire structural design, systems integration, and manufacturing processes were built around the RB211's specifications. Switching to alternative engines would require redesigning the wing structure, nacelle attachments, fuel systems, and control interfaces. Rolls-Royce hemorrhaged money as RB211 development costs spiraled beyond all projections. The British government provided emergency funding to keep the program operational, but the engine manufacturer's financial stability deteriorated throughout 1970. Their contract commitments to Lockheed became increasingly questionable as losses mounted. Meanwhile, Lockheed's production lines prepared for TriStar assembly based on delivery schedules that assumed successful RB211 certification. The company had accepted orders from Eastern Airlines, Transworld Airlines, and multiple international carriers, all contingent on receiving aircraft powered by engines that had never completed a full test program. The same innovative spirit that created the Constellation's breakthrough design now threatened to destroy Lockheed's commercial aviation operations entirely. Their commitment to technological advancement had created a single point of failure that no amount of engineering excellence could overcome. The TriStar program's success depended entirely on a foreign company's ability to deliver revolutionary engines on schedule and within budget. This dependency represented a fundamental shift from Lockheed's historical approach to aircraft development. The Constellation succeeded because it integrated proven technologies in innovative ways. The TriStar gambled everything on unproven technologies that promised revolutionary performance, but delivered unprecedented risk. Lockheed had transformed from a systems integrator into a hostage of their suppliers' engineering capabilities. The company's entire commercial future now rested on decisions being made in boardrooms thousands of miles away in London. The phone call that stopped production forever, February 4, 1971, started like any other day at Lockheed's Burbank facility. Production lines hummed with activity as workers assembled TriStar fuselages, installed advanced avionics systems, and prepared mounting points for the revolutionary RB211 engines that would transform these aluminum shells into operational aircraft. Orders from Eastern Airlines, Transworld Airlines, and international carriers filled the production schedule for months ahead. Then came the phone call that ended Lockheed's commercial aviation future forever. Rolls-Royce had entered receivership. All RB211 engine production stopped immediately. The British company that Lockheed had trusted with their entire commercial aviation strategy was bankrupt, leaving hundreds of partially completed TriStars stranded on assembly lines without power plants. Despite severe delays and cancellations, Lockheed eventually built and delivered about 250 L-1011 TriStars, and the type entered airline service in 1972. The Rolls-Royce collapse stemmed directly from the RB211's spiraling development costs. The switch from carbon fiber to titanium fan blades after the original composite materials failed. Bird strike tests had increased manufacturing expenses far beyond projections. The three-spool architecture required extensive redesigns of bearing assemblies and shaft balancing systems. These engineering challenges consumed resources that Rolls-Royce simply couldn't sustain financially. The magnitude of this disaster becomes clear when you understand the TriStar's design constraints. Lockheed couldn't simply install different engines on existing airframes. The aircraft's S-duct configuration for the tail-mounted engine was sized precisely for the RB211's diameter and airflow requirements. The wing-mounted engine pylons were engineered for the RB211's weight distribution and thrust characteristics. Even the fuselage cross-section incorporated structural elements optimized for this specific power plant's installation requirements. Boeing and McDonnell Douglas recognized the opportunity immediately. Their wide-body aircraft offered multiple engine options from established manufacturers like Pratt & Whitney and General Electric. Airlines could choose power plants based on their operational requirements and maintenance capabilities, while Lockheed's customers faced an indefinite production halt with no alternative solutions. The financial mathematics became catastrophic within weeks. Lockheed had invested over $900 million in the TriStar program by early 1971. But every aircraft on the production line was now worthless without engines. New orders evaporated as airlines switched to Boeing 747s and McDonnell Douglas DC-10s that could actually be delivered with functioning power plants. However, the true scope of Lockheed's crisis extended beyond stranded aircraft. The company's entire cash flow structure depended on TriStar deliveries to generate revenue that would fund ongoing production and development costs. Without deliveries, Lockheed faced immediate liquidity problems that threatened their entire operation. By mid-1971, the company's liabilities exceeded their assets by $38.5 million. Internal financial analyses revealed the program needed to sell between 195 and 500 aircraft just to break even, depending on accounting methodologies and cost allocation assumptions. But with production frozen indefinitely, new sales were impossible while existing customers demanded refunds or contract modifications. Banks refused to provide additional funding without government loan guarantees. Commercial lenders viewed Lockheed's situation as hopeless, a company that had bet everything on unproven technology and lost. The same financial institutions that had funded Lockheed's expansion during their Constellation success now saw the company as an unacceptable credit risk. The same company that once was a leading post-war airliner maker now faced a serious corporate crisis. Lockheed had become America's largest defense contractor with $1.5 billion in annual military contracts. But their commercial aviation division was hemorrhaging cash so rapidly that bankruptcy appeared inevitable within months. The question facing Washington was unprecedented. What happens when a critical defense contractor's survival depends on political intervention? The single vote that saved America's defense giant. The Nixon administration confronted an unprecedented dilemma by August 1971. Lockheed operated as America's largest defense contractor, managing $1.5 billion in annual military contracts that were critical to national security operations. However, the same company was hemorrhaging cash so rapidly from the TriStar disaster that bankruptcy appeared inevitable within weeks. The Emergency Loan Guarantee Act of 1971 represented the federal government's first major intervention to prevent a defense contractor's collapse. The proposed legislation would authorize $250 million in loan guarantees, allowing Lockheed to secure private financing that banks refused to provide without federal backing. The act would establish the Emergency Loan Guarantee Board specifically to provide such assistance to major businesses whose failure could impact the economy. However, this bailout proposal faced fierce resistance from legislators who viewed it as government interference in free market operations. The House of Representatives passed the bailout with a narrow margin of 192 in favor to 189 against. This razor-thin three-vote difference demonstrated the deep philosophical divisions among lawmakers regarding government intervention in private corporate failures. The close vote also set the stage for an even more contentious battle in the Senate, where opposition was expected to be stronger. Senator William Proxmire led the opposition campaign, arguing that the bailout represented a fundamental violation of free market principles. He condemned the proposal as socializing corporate losses while allowing private companies to retain their profits during successful periods. Proxmire's position reflected concerns that Government bailouts would create moral hazard, encouraging companies to take excessive risks, knowing they could be rescued by taxpayer funding. Economist Alan Greenspan provided intellectual ammunition for bailout opponents by warning that saving Lockheed would establish a dangerous precedent for future corporate rescues. His analysis suggested that such interventions could destabilize the entire free market system by shielding large companies from the financial consequences of their poor decisions. Greenspan's warnings proved prophetic, as government bailouts became increasingly common in subsequent decades. However, Lockheed's supporters mobilized an unprecedented lobbying campaign to counter the opposition. Aerospace workers organized letter-writing campaigns targeting key senators, while union representatives testified before congressional committees about the economic devastation that would result from Lockheed's bankruptcy. The campaign extended beyond traditional lobbying, with some citizens organizing boycotts of Wisconsin cheese and beer to pressure Senator Proxmire's home state constituency. The Senate vote became one of the most dramatic moments in congressional history. When the final tally was completed, the result was 49-48 in favor of the bailout, saving Lockheed from immediate bankruptcy and establishing the precedent for government intervention in corporate financial crises. The vote's aftermath revealed the profound implications of this decision for American economic policy. The Emergency Loan Guarantee Act created the first modern corporate bailout mechanism, establishing procedures and justifications that would be used repeatedly in future financial crises. The legislation authorized government backing for private loans to a failing company based on its strategic importance to national defense. However, the bailout also exposed fundamental contradictions in American free market ideology. The same political leaders who championed private enterprise and opposed government regulation were willing to intervene when corporate failures threatened defense capabilities or employment levels in their districts. The precedent established in 1971 would echo through American economic policy for decades, from Chrysler in 1979 to the financial sector in 2008. But Lockheed's survival came at a cost that extended far beyond taxpayer guarantees. The company's financial crisis had attracted congressional scrutiny that would soon expose activities far more damaging than engineering failures or cost overruns. The bribery network that toppled governments. Congressional investigators discovered that Lockheed's financial problems were just the surface of a far more extensive criminal enterprise. Over 2 decades, from the late 1950s through the 1970s, Lockheed had systematically paid approximately $22 million in bribes to foreign officials across multiple continents. The corruption network extended far beyond simple business facilitation payments, involving organized crime networks and illegal currency transfers that would topple governments and destroy political careers. The Japanese operations represented the most extensive corruption scheme in Lockheed's international network. The company paid over $12 million specifically to secure all Nippon Airways orders for the TriStar aircraft. These weren't subtle consulting fees or legitimate business expenses. The money moved through Yakuza criminal organizations, with cash literally transported in golf bags from Hong Kong to Tokyo to avoid banking regulations and government oversight. Yoshio Kodama served as Lockheed's primary intermediary in Japan, using his connections within organized crime networks to facilitate payments to government officials and airline executives. The cash transfer system operated like a sophisticated money laundering operation, converting corporate funds into untraceable currency that could be distributed to recipients without creating official records. The payments included 500 million yen to Prime Minister Tanaka, 160 million yen to ANA officials, and 1.7 billion yen to Kodama himself. The scandal's political consequences exceeded anything Lockheed's leadership had anticipated when they authorized these payments. Japanese Prime Minister Kakue Tanaka was arrested on July 27, 1976, on charges of violating the Foreign Exchange and Foreign Trade Act, marking the first time in Japanese history that a sitting prime minister faced criminal charges for crimes committed during his term. Tanaka's conviction in 1983 resulted in a 4-year prison sentence, though he remained free on appeal until his death in 1993. However, the corruption network extended far beyond Japan's borders. In Italy, President Giovanni Leone resigned in disgrace after investigations revealed his involvement in defense procurement corruption linked to Lockheed's military aircraft sales. The Dutch royal family suffered permanent damage when Prince Bernhard was discovered to have received $1.1 million in payments from Lockheed, fundamentally compromising the monarchy's reputation for political neutrality. The scandal reached increasingly bizarre dimensions as investigations revealed the full extent of the criminal networks involved. An actor crashed a plane into the home of a Yakuza intermediary before committing suicide, demonstrating the violent consequences of the corruption schemes. These incidents exposed how Lockheed's bribery operations had become entangled with organized crime networks that operated according to different rules than conventional business relationships. By February 13, 1976, the political and corporate fallout had reached Lockheed's executive leadership. Chairman Daniel Houghton and President Carl Kochian both resigned as the full scope of the bribery scandal became public. The resignations represented an acknowledgement that the corruption had occurred at the highest levels of corporate decision-making, not as isolated actions by rogue employees. The scandal even threatened to destroy Lockheed's military operations, which had remained profitable throughout the commercial aviation disasters. Skunk Works legend Kelly Johnson, the designer of the U-2 spy plane and SR-71 Blackbird, nearly quit in disgust over the corruption revelations. Johnson's near departure would have been catastrophic for Lockheed's classified programs, which represented the company's most valuable capabilities. Senate investigations during 1975 and 1976 revealed that the TriStar bribery was part of a much larger pattern of corruption. Lockheed had paid bribes to secure sales of F-104 fighters in West Germany and the Netherlands, C-130 transport aircraft in Italy, and various other military systems across multiple countries. The company's defense operations weren't immune to the same corrupt practices that had characterized their commercial aviation efforts. The bribery revelations led directly to the Foreign Corrupt Practices Act of 1977, which President Jimmy Carter signed into law on December 19, 1977. The legislation made it illegal for American companies to offer payments to foreign officials for business purposes, fundamentally changing how American corporations could operate in international markets. Yet even as these scandals destroyed Lockheed's public reputation and threatened their survival, one division of the company operated according to completely different rules, the profitable secret that kept Lockheed alive. The Skunk Works division generated consistent profits through an entirely different business model that protected it from the competitive pressures destroying Lockheed's commercial operations. Founded in 1943 by Kelly Johnson, this secretive division completed projects like the P-80 Shooting Star in just 143 days, establishing Lockheed's reputation as America's premier military aircraft manufacturer and positioning the company to receive contracts for increasingly sophisticated aircraft. The contrast between military and commercial aerospace markets reveals fundamental economic differences that determined Lockheed's survival. Commercial airlines demand the lowest possible acquisition costs and operate on razor-thin profit margins with fierce competition on every contract. Military procurement follows completely different economics, where capability matters more than cost, and performance specifications drive purchasing decisions. Military procurement operates through guaranteed contracts with built-in profit margins that protect contractors from the financial risks inherent in commercial aviation. Defense programs receive funding authorization before development begins, eliminating the cash flow problems that plagued the TriStar program. The Pentagon's acquisition process also allows for cost overruns and schedule delays that would destroy commercial aircraft programs, providing financial stability that airlines never offer. The protection that classified programs provided for Lockheed's most profitable operations cannot be overstated. The Skunk Works developed aircraft like the U-2 spy plane and SR-71 Blackbird under security classifications that shielded these programs from public scrutiny, congressional oversight, and competitive bidding processes. This secrecy created a business environment where technical performance justified any development costs. While Lockheed was bribing foreign officials to sell TriStars to price-conscious airlines, their military division earned premium prices from a single, loyal customer. The Pentagon valued advanced capabilities over cost efficiency, creating profit margins that commercial aviation could never match. Defense work offered predictable revenue streams spanning multiple years, unlike commercial aircraft sales that depended on airline financial stability and market conditions. Military contracts included provisions for research and development costs, spare parts support, and system upgrades that generated ongoing revenue long after initial deliveries. Commercial airlines demanded fixed prices and often negotiated penalty clauses for late deliveries or performance shortfalls. The classified nature of military programs also protected Lockheed from the reputation damage that destroyed their commercial operations. Corruption scandals and technical failures in civilian aircraft became front-page news, while military program problems remained hidden behind security classifications. The Skunk Works maintained its reputation for engineering excellence, even as commercial aviation disasters dominated public perception of the company. Lockheed's leadership gradually recognized that military work offered superior profitability without the competitive pressures of commercial markets. Defense contracts provided guaranteed funding, protected profit margins, and insulation from public criticism that commercial aviation could never match. The company discovered that serving a single customer with unlimited resources was more sustainable than competing for price-sensitive airline contracts. And the Pentagon's willingness to fund cutting-edge technology development contrasted sharply with airlines' demands for proven, cost-effective solutions. Abandoning competitive commercial markets for exclusive military work represented more than a business strategy change. Lockheed transformed from a company that served multiple market segments into a specialized defense contractor focused entirely on government requirements, eliminating the financial volatility and reputation risks that had nearly destroyed the company while preserving the innovative engineering culture that made their military programs successful. This transformation would prove to be the most profitable decision in aerospace history. The company's strategic pivot from commercial aviation to exclusive defense contracting established a business model that continues to dominate aerospace today. Lockheed Martin now generates over $60 billion annually, focusing entirely on military systems like the F-35 Lightning II fighter program. The 1971 bailout was terminated in 1977 when Lockheed refinanced privately, but the precedent of government intervention in corporate failures became permanent American policy. Every major bailout since then traces back to that single Senate vote that saved Lockheed from bankruptcy. The corruption scandals led directly to the Foreign Corrupt Practices Act of 1977, fundamentally changing how American corporations operate internationally. Aviation's most spectacular scandal demonstrated that in aerospace, reputation and reliability matter more than innovation, a lesson that would echo through the industry for decades.